The internal structure of the air engine with a disc for Taiwan is very simple, consisting of only one disc and a Z-shaped shaft. All plastic parts are 3D printed. A small bearing is inserted into the bushing, and after snapping it into the center of the disc and securing it with the ruixing shaft, the other half of the disc is installed, which is very slippery. Now it is equivalent to the piston and crankshaft being integrated into one unit, similar to the previous rotary engine. When this thing spins, it's like a gyroscope on Quail Island, with the notch aligned with the protruding position of the cylinder. A gasket is added at the cylinder connection to prevent air leakage, tighten the fixing screws, and add a little oil to it. This increases lubrication and sealing. With the cylinder's protruding position, the disc will not rotate with the Z-shaped shaft. It can only oscillate like this, with air coming in from the inlet, causing the disc to start tilting and oscillating, which drives the Z-shaped shaft to rotate. As the disc continues to tilt, the airflow below decreases and the airflow above increases. Once it reaches the top of the economic grid, it completely closes, and all the air enters below. Continue to drive the V-shaped shaft to complete the other half of the rotation, switching back and forth continuously in a cycle, and the engine is formed. The principle is that simple. The intake and exhaust are interchangeable and can be swapped. The only challenge is the sealing with steel. Air comes in and compresses these areas, forcing the disc to tilt and oscillate. If there is a leak at this position, it won't work. If using a sealing ring, it might work on the top, but it's not guaranteed below. Instead, directly cut and drill a 1 mm thick rubber sheet. Doing it this way works, as it can seal the critical position of the disc without air leakage. The cylinder and the end cap are also sealed in the process. Secure it with 6 screws. The Z-shaped shaft is not installed for now. Let's test if it works first. Why isn't it moving? What does this mean, huh? Is it too tight here? I changed an end cap, leaving only the outer ring part. Let's run it and see if it moves. Big brother Ma and little Ma. It's working, it's fine. Pay attention, when the air enters, it will lift the disc up a bit and stop at a right angle. Once this is cooked, changing this action to an oblique angle can solve the problem. I reprinted it, and now once the air flows, the disc can swing normally. Look at how good this is normal. After installing the V-shaped shaft, it can rotate normally, without any stuttering. Finally, install the protective shell, then add some oil into the cylinder. A friend lent me a pressure machine, and he hasn't even used the helmet yet. Start by using air, beginning with low pressure, and give it a little help. Because it's quite simple. It's not even 28 yet, and the voltage can operate like this. You can really see the disc inside, moving from the air outlet, which can automatically switch to open and close the air hole. Turn it off first. Now it's rotating clockwise, pull out the air tube, and install it on the other side to open it. See? Now it's rotating counterclockwise again. Increase the air pressure a bit and give it a try. It's still okay. Approximately 850 revolutions per minute. Let's test the black pen fusion again to easily observe the internal operation. All the components are exactly the same. Once the propeller is installed, it spins just as smoothly. Now, the issue lies with its premium supervisor, whose core is a non-rotating oscillating disc. It doesn't rotate with the axis, but performs a swinging motion, allowing power to be directly transmitted to the drive shaft. This type of engine doesn't have complex connecting rods, and even the intake and exhaust are completed by the oscillating disc. The structure is simple, and air maintenance is also convenient and quick. The maximum rotational speed is achieved. As mentioned yesterday, it should be fine, and it can also be used specifically for rooms